Okay, so I just want to take a new topic today. Okay, we have one topic left out in BGP. Might be I'll take this after a few classes. Okay, we have gone through a lot of BGP classes. I just don't want to pressurize with a lot of hard topics. Okay, so on a lighter note, let's take something which is very easy to understand, and most probably you guys are aware of this topic. It's called as redistribution. Okay, so the topic for today would be redistribution. So where do you think we use redistribution? Does anyone know where do we use redistribution, and what is the what does redistribution does? Yep, great. Yeah, so let me tell you what is redistribution and where exactly we use this. Okay. Okay. So let's say we have two protocols. It could be any protocol. It could be connected. That means directly connected. Static routes, RIP, EIGRP, OSPF, BGP, ISIS. So it could be any routing protocol. Let's say if I have to inject one of them into other. Okay, so a simple example. Let's say I have a enterprise. Okay, and we all know in the enterprise, in the LAN, we make use of the dynamic routing protocol, right? So let's say I have OSPF running here and all my users are connected over here. Now if they want to move towards internet, how is their packet gonna go? So their traffic will hit the routers, which is OSPF. OSPF has to push the traffic towards the core router, and now you know that core router don't have any kind of dynamic routing. It's your BGP that will be facing towards ISP. Agree? So how is OSPF gonna get injected to BGP, and how is BGP gonna send it towards internet? And similar way, while coming back, the return traffic will hit the BGP, and BGP is gonna redistribute back to OSPF, and that's how you gonna get the file or the image or videos, whatever you were trying to download, access, upload, anything, right? So it was between two different protocols. The first protocol being called as OSPF and the second protocol called as BGP. Okay, so in this scenario, OSPF is acting as source, right? This is the source. It is the first protocol that is being hit by the user, and this BGP act as a destination. Okay, so in terms of redistribution, there are two words. One is called as source and the other one is called as distribution. OSPF act as source and BGP act as destination. Now let's say while for the return traffic, so whom is it hitting? It's hitting BGP. So now source is your BGP and BGP is redistributing back to OSPF. Now that's called as OSPF, or the destination is OSPF. Okay. So in distribution, there are two things. One is called as source, the other one is destination. Source is one which is gonna advertise the prefix. Okay, and destination is one where you gonna put or where you're gonna inject them, right? So in this case, let's say OSPF towards BGP. Okay, so the routes behind OSPF, Okay, so let me write it in this way. Routes which are behind OSPF are gonna get injected inside BGP. Okay, so we call destination is where we get injected. Source is where we are trying to advertise multiple networks. So those could be like 192 series or 172 series, and these network has to be injected within BGP. So BGP act as your destination, and it goes according to your BGP neighborship and all the routings that we have learned. Okay, so let me open up the PDF. So let's see what the PDF is gonna say. So PDF says that redistribution always encompasses two routing protocol. That's mandatory. Okay, a redistribution happens when you have two routing protocol. One is called as source, the other one is called as destination. Source is when you're having some prefixes which you need to inject it to the destination protocol. Okay, so destination is where you're gonna inject them. Redistribution configuration under the destination protocol identifies the source protocol. Okay, and basically you don't want every routes to be injected. That's one more criteria. If I have a BGP, I have my all other routers which have OSPF. Okay, so I don't want every routes to be injected, right? If I advertise by default all the routes to BGP, BGP will take everyone to internet. So I don't want that. So let's say I have some servers which are meant to be only in the LAN. They are not meant to have internet access. So you cannot redistribute this network within BGP. Okay. So for that, what we do is we make use of filtering. We make use of filtering, or we also call it as uh, modification, route modification or filtering with the help of route map. So you know what is route map? We have configured in BGP scenarios. So in BGP, I have shown you how we configure route map. I have to define a word, I have to define the matching parameter, and then I have to call it in my process. So similar way in the redistribution, I don't want all of my prefix to be getting redistributed to BGP, which will lead to internet access, and that could lead to vulnerability as well, right? So in order to avoid any kind of breaches, we can filter them. We can just make or we can just redistribute only those prefixes which we need, and rest we don't have to do that. Okay, so that's from the security point of view. Okay, let me tell you some key points for redistribution. The first main thing for a redistribution to happen is the prefixes should be advertised in your local router. That's the main thing. If there is no prefixes in your router information database, then that network will not get redistributed. Okay, so that's the first criteria. Second criteria here is which is not mandatory, but I can say it's additionally. So source protocol, okay, that you're gonna distribute into the destination should be acting as the source of that route. Okay, so let's say I have EIGRP and I want to redistribute to BGP. So this EIRGP should be acting as a source for that network. So let's say I have 1.1.1.1 and I want to redistribute 1.1.1.1 inside BGP. So EIRGP should be acting as a source in the sense source header. Okay, so this is one more criteria. The second criteria is that the source protocol must be the source, and it should be in the RIP. Okay, so if let's say you are trying to inject 1.1.1, okay, that's something what you want to inject here, and in your configuration you are gonna say that you are doing it from EIGRP to BGP point of view. but inside RIB, this route is being learned by OSPF. Now that's a misconfiguration. Okay, that's why the second point is very important. So whatever you're trying to redistribute between the two protocol, so that must match along with the RIB or the routing information. So let's say you're configuring routing, you're configuring redistribution between BGP and EIGRP, but your OSPF is a best preferred for 1.1, then that's gonna not redistribute. Okay, so you need to see these 2 points. uh, while if you see if there is any uh, issues with your redistribution routes, or if the it's not working, then you need to see this 2 points mainly. Okay, okay, there are couple of factors for your redistributions. Okay, uh, one of such factor is called as, it's not a transitive, it's not gonna be transitive. That means, let's say I have EIGRP over here, I'm gonna inject it inside OSPF, and then finally I'm gonna inject back towards, not back, towards BGP. Okay, I mean to say I have some routes 4.4.4.4, and I'm gonna inject it to OSPF. Okay, now OSPF is not gonna distribute or not gonna redistribute those 4.4.4 towards BGP. Okay, so that's a main thing. It's not a transitive type of protocol. So how do you achieve in case of double redistribution? Let's say from EIGRP to OSPF, and if you want to push it from OSPF to BGP, how can I achieve that? So we call it as mutual redistribution. Okay, mutual redistribution. If you remember, in the case of IBGP full mesh, okay, in case of IBGP full mesh, I said virtually we need to configure the neighborship, right, in this way. Then they are acting as a full mesh. So in similar way, in the case of mutual redistribution, I need to virtually configure or virtually redistribute the mutual ones. Okay, so let's say in the case of router EIGRP, I'm still gonna redistribute the BGP routes even though they are not directly connected. And similar way here, in the case of router BGP, I'm gonna redistribute the EIGRP routes, and then they form a mutual connection or a mutual redistribution. So basically this is acting as a mutual here. Okay, so how would be the configuration for a mutual is, so let's say from this point of view, I have router EIRGP. Okay, and let's say I was only redistributing OSPF. Let's first talk about the default configuration. Okay, and from OSPF point of view, I had OSPF and I was redistributing both of them, like EIGRP and also BGP on the other side. Okay, and from the BGP side, router BGP 65,000, I used to redistribute OSPF only the adjacent ones, right? Now in the case of mutual, what happens is I need to redistribute BGP, okay, over here, and similar way I have to redistribute EIGRP. Okay, and then you can just redistribute the routes between multiple protocols. Okay, so then that's possible. Otherwise, by default, redistribution act as a non-transitive. So it's gonna between only two protocols. The third protocol will not get whatever is the first one going to advertise. Okay. So I have mentioned all these things in the PDF, which you can refer back. I'll also go through the PDF once after this. Okay. Okay. So when I'm redistributing something within another protocol, let's say I'm redistributing OSPF inside BGP, right? So you know that OSPF is a SPF algorithm protocol. It's a link state algorithm and it follows metric for path calculation. Whereas BGP on other side, it's a path vector protocol, right? It's a path vector protocol. It doesn't follow metric. It follows some attributes. So how are you gonna inject OSPF inside BGP so that BGP can take it further towards ISP, right? So there should be some common or a similar attribute or a similar concept which make this and this in the same platform. I can say that they can understand what is what. So OSPF metric must inject inside BGP so that BGP take it in this way, because BGP is not going to understand what is OSPF metric. It will only understand what are attribute, right? Now that concept is called as seed metric. Okay, in redistributions we call that a common platform who is bringing OSPF and BGP in one single platform. I'm not talking about only for OSPF and BGP. It could be for RIP or EIGRP to BGP. It could be any between any two protocol. There will be a common platform for the protocol to understand each other, right? To redistribute take place. So that is called as seed metric. Okay. So we are gonna see for each protocol what are the seed metric and what are the different ways to configure the seed metric. The normal way which you have checked out so far would be router, let's say OSPF, and you want to redistribute EIGRP. So you might have done something like this so far, right? So this is one way. There are two more ways which I'll discuss in today's class. Okay. So this thing, what we just write after the injecting route, that's called as seed metrics, and each protocol has its own seed metric, and they also have some default seed metric also. But we usually don't keep default. Instead, we change it accordingly to our requirement. We don't keep it. But yes, if you don't set any values, they are gonna take the default ones. Okay, and I'm gonna tell you what are the default for the protocol. What by default, what is OSPF gonna have, or what is BGP gonna have. So every protocol has its own default value as well. Okay, so in the case of EIGRP and RIP, by default the seed metric is gonna be infinity. Okay, so any routes, if you have a seed metric of infinity, they are not going to get installed in the EIGRP topology table. Okay, they're not gonna get. So we have to manually say that bandwidth is this, MTU is this, delay is this, reliability is that, because EIGRP works on 5 different factors, right? Bandwidth, MTU, delay, load, and reliability. If you don't set it, and if it's by default taking infinity, then that route is not gonna get advertised. Okay, so you need to manually define these whatever you are injecting, you need to define those subnets in this format. In the case of OSPF, the good point is your routes are not gonna get invalid, because by default OSPF will consider it as 20 metric. Now that's a good point for OSPF, and if you have if you are redistributing inside OSPF, it's very simple because you don't have to take care of many things in case of OSPF. That's why when I am trying to redistribute inside my OSPF, I just give a single command called as subnet, right? Because by default it's gonna take as metric 20, so I don't have to worry for my lot of factors like so and so, right? In case of EIGRP, I have to define all 5 of them, but in case of OSPF, it's by default 20, and I just need to say subnet. Subnet in the sense all the prefixes that I'm gonna inject it. If I have 5 prefixes, what I'm gonna inject it or what I'm gonna redistribute, so I need to call it as subnet so that each one of them get redistributed. Okay, so this is by default. Okay, in case of BGP is injecting inside OSPF, then by default the seed metric is gonna be 1. Okay, so OSPF and any other routing protocol will have default 20, and OSPF and BGP will have 1. In the case of BGP, the things are very different because BGP don't understand either this neither this. It is a path vector protocol. Okay, so if you are injecting something, any IGP or EBGP to IBGP, BGP only understand in terms of attributes. Okay, so the what kind of attributes that it needs to know so that route is functional. One is origin. Okay, so you have 3 type of origin: I for IBGP, E for EBGP, and a question mark. If you remember, during the show IP command, show IP BGP command, we see something called as question mark, and question mark is something which is used for the redistributed routes. Okay, so origin is very important. Second, you need MED, which is multi-exit discriminator, and you're gonna just set whatever values it is. So basically it will be most of the time 0. Okay, for IGP and all internal it will be 0. And the last one here is your weight. So if you have the weight of 32768, it means it's locally originated. So these are the 3 uh, attributes, or these are the 3 seed metric for BGP. So whenever you redistribute something, so it must know these values and then they are gonna be functional. Okay, but in the case of EIGRP, you see there are multiple things that you need to configure. In OSPF, it's by default it will consider the values either 20 or 1 depending upon the protocols, and in the case of BGP, you just redistribute and they are gonna uh, take it. So this is a automatic uh, value, right? Origin is something automatic, you don't have to define something. Med is also gonna be automatic, and weight is also gonna be automatic. You don't have to configure anything. It's by default gonna take it from where or what route are you injecting. It depends on that, and it will automatically take this. So the configuration lies only for EIGRP, which we need to see. If let's say I want to have path manipulation, then I can change these values and I can make use of the better path in case of EIGRPs. Okay. Okay. So as I told you, the command for redistribution would be, so let me show you directly over on the GNS. Okay. So if you remember, I have used this router, this one, and this one. Okay, so previously while working out for OSPF external routes, we have already configured redistribution. So we used this router. So this router act as a redistribution router, this act as OSPF, and over here I have EIGRP. Okay. Okay, and how is this command looks like? So let me show you that. So let's see what do I have here. So do I have OSPF? No. EIGRP? No. Okay. So anyway, what I'm gonna do is I'll just take one of the process. Okay. So this is let's say OSPF1. Okay. The configuration or the command line to configure redistribute is redistribute. You just need to define the protocols that you are gonna inject. Okay. Now in this case, this is acting as your destination. Okay. Who is your source? Source could be any one of this. So let's say you are injecting EIGRP. So when you are injecting EIGRP inside OSPF, so you know that OSPF by default is gonna take 20, and if it was a BGP, then it was gonna take 1. So it is very simple in this case. So for EIGRP, just define the AS number. Okay. So that whatever you have within EIGRP1, the prefixes within EIGRP1, they are gonna get considered. Okay. And then you're gonna say subnet. Subnet is in the sense all the subnets that you're gonna have inside EIGRP, and that's all. Okay, just one single command. You don't have to configure any metric or all those things. Okay, because by default it's gonna take 20. But yes, if you want to change the value, you can change it over here. Okay, now same thing, the similar way I'll show it when you have the destination to be EIGRP. Okay, and you need to have those 5 components that specifically to be mentioned. Okay, so let's say the process is 1. Okay, and if I want to redistribute the OSPF routes, so I'm gonna say what is the process ID. Okay, so there is nothing called subnet now. I need to say metric. Okay, there's no other option. I need to say metric, and let's see what else I have within metric. So you see, it's asking me for bandwidth, so I have to say bandwidth. Okay, it's asking me for delay now, so let's say I need to configure delay as well. It's asking me for reliability, so let's say it's a reliability, right? So let's say for a if I do a question mark, it says to set the load. Okay, so I'm gonna say 100% or whatever it's. Okay, I'm gonna set some MTU values. What else? That's all. That this whole thing in the case of while injecting inside EIGRP, because EIGRP, if you don't specify, it's gonna be infinity, and infinity is not gonna get inside routing table. So you have to specify this. Okay, in case of in case of OSPF, you need not to, because by default it has some value. It's not gonna be infinity. So it will be either 20 or it will be either 1, and it's good, and they are gonna be in the routing information base, right? What are the 2 condition for routing for a redistribution is, first it should be inside RIB, and second, the source protocol, whoever is injecting, must be the source for that particular route as well, right? These 2 should be served. Okay, if you want to see for BGP, similar way, let's say if I want to set for BGP, and let's say I'm redistributing OSPF routes. So you know that BGP is a path vector. It's not a it doesn't know what is a metric. So what I'm gonna do is, let's say I define metric, let's say metric 10. Okay, and that's all. Just leave it. So it's gonna see that who is the origin, what is the met, and what is the weight, and then it's gonna get its own attribute, and it's good to run. Okay, so they don't need any metric, or they don't need any cost for them to be functional. They just need the attribute, and those 3 attributes are the theoretical attributes, not those numerical kind of thing which we can change, like in case of AS path, local preference, and weight, we could change them, right? I had some command, but in the case of redistribution, those are med and what else you have, med and origin and uh, weight. So these are something which automatically gets detected up. Okay, so these were three commands in the case of redistribution. I'll also come back to this. Okay, there's one more theoretical topic, very easy topic, that's called as selective redistribution. Okay, so we make use of this concept specifically when the routes are redistributing from BGP to IGP. Okay, so let's say I have BGP and over here I have OSPF. All my internet routes, so you know that over internet you have like close to 8 lakhs of route, right? So you don't want all the routes getting redistributed. So this is a topic, or this is a concept where you are gonna have selective route redistribution, and that's what I told in the beginning, that we also have concept of route filtering in the case of redistribution, right? If you would have wondering where we need this filtering in the case of redistribution, so it's when if this is one scenario, it could be from uh, it could be when the packet flow is going from LAN to WAN as well. You don't want all of them to be exposed to internet, so you can filter couple of subnets, okay, or couple of routes or a prefix you do not want to get redistributed. So this is called as selective redistribution. Okay, the topic is called as selective redistribution. Okay, now the three types of configure, or three ways to configure those seed metrics. So you know what is seed metric now. Okay, so in the case of router OSPF, what was the seed metric? It used to be redistribute, EIGRP, 1 and subnet. Okay, so this was a seed metric in the case of OSPF. Similar way, let's say I have EIGRP, okay, and if I'm redistributing OSPF, so what all things I need to have? The 5 components, so they are acting as the seed metric. Okay, and so as same with the BGP as well. So whatever component you need, so basically in case of BGP you don't need anything, it's a path vector. So whatever you set here, a metric command or just a normal command, that act as a seed metric. Okay, so this is one way of configuring. So I can also call it as a legacy method, right? So this is something which we've been doing. Now what is the second way of configuring redistribution? So I can also configure redistribution with the help of a command called default metric. Okay, so with the help of default metric, I can also configure redistribution, and the command would look like, let's say router EIGRP1, autonomous system 1, and I can write default metric. I can define everything, like it's a 10,000 of bandwidth, is a number 1, 255, 1, 1500. So basically the components, okay, bandwidth, delay, reliability, MTU, load, okay, and then I can define my network statement, whatever network I wanna advertise, and then I can say redistribution OSPF, just OSPF number. I don't have to do anything, okay, or else if you see in this case I had to write all the parameter next to OSPF, but in the second method, when I am making use of default metric command, I can have it separately. Okay, Fine. What is the third method? Third method of doing the reconfiguration commands, or a CLI commands for redistribution. So the third method would be route map. Okay. So let me tell you, if someone asks you that there are all the three ways present on your router, the legacy method is present, the default metric is present, and also the route map is present. Now, which one will be preferred? So let's say you had some values different from this and this, and similar way you had very different value over here. So three same thing but with three different values. So which method would be preferred? So it's your route map that's gonna take the first preference. Okay, this is the preference. This is the first preference. And how do we write? So let's say I have route EIGRP and AS number. I'm gonna define the network statement that we know for EIGRP. I'm gonna write redistribute statement. Okay, I'm gonna say it's a OSPF, and instead of writing any components or any parameters, I'm gonna say that route map, okay, and a word. It could be any word which is easier for you to understand. So I can say it is a redistribute or something, and then I come over here and then I define my route map, the same word, okay, and then I'm gonna set the metric here with the command set metric and all the required things. So this is the configuration in the case of route map. Okay, so these are the three ways we can configure redistribution. One is the legacy method, default metric, and the finally route map. Same goes with all other protocol. Okay, so the same, I just gave you an example for EIGRP, but the same process or the same method, the three methods also is applicable in OSPF and BGP as well. Okay, just once again a quick summary of what is redistribution in the case of BGP. So you know that it's a path vector, so it doesn't need to know any metric. Okay, so what are you gonna inject, or what is the redistributed routes will be consisting of? So the redistributing routes will be consisting of those three parameters. One is the origin. Okay, so you will see origin to be question mark, which is nothing but incomplete. So I think I have this in the PDF. So once you go back and once you're revising, so you will just recall what I'm trying to say. Okay, so you see this BGP origin question mark, which is incomplete, right? So that's in the case of redistribution. The next hop will be set to the IP address of the source protocol. Okay, the weight will be set to 32768, and the med is nothing but, the metric is nothing but that will be considered of the source protocol. Okay, whatever is injecting inside BGP. So that is all about redistribution. Okay, I have one lab to demonstrate this, and lab is something which is we have seen, which is what we have seen in case of the previous lab also. So I say that the first router, that's Mumbai router, okay, this act as a OSPF router, this act as EIGRP router, and this is gonna act as a redistribution router. Okay, so in other word, redistribution router can also be called as a translator which knows both of the protocol. So this is a router which will know about the OSPF And similar way, this is the router which is gonna know about the EIGRP on the other side. Okay, so let me show you this lab. Okay, and might be after the class or during the weekend, you can give a different possibilities like route like OSPF with BGP or BGP with RIP or a static route. Okay, as of now I'm showing you for OSPF, OSPF redistribution, and over here EIGRP. Okay, so basically between OSPF and EIGRP. So let me open up these routers. So I have Mumbai router 4, 6 and Tokyo router 7. So I guess there is no configuration. Okay. So if I see what are the IPs, so I only have IP address. Okay. What about OSPF? Okay, there is no OSPF process. So let's configure OSPF process. So let's say or let's go with the interface way. Okay, so there are two ways to configure OSPF. One is global way, other one is interface way, right? So if I go to interface 0/1, if I say IP OSPF, what is the process ID 1, what is the area? It's going to be 40. Okay, and yes, I need router OSPF, not here, in the next router for redistribution. So let's say I go to Mumbai router 6. So first let's see what do I have. Do I have OSPF? Okay, and what is EIGRP here? Okay, so I'm not sure what are those values, so I'll just reload this. Okay, so I have a router where I can configure my configuration. So on the Tokyo R7, let's see if I have some EIGRP. Okay, I don't have anything. Fine, so let's configure EIGRP. Let's advertise, but what are the networks that I need here? Okay, so these are the two networks which I can advertise. Okay, 23.23.0. Okay, it's gonna ask for wildcard mask. Okay, and similar way I'm gonna redistribute, or I'm gonna advertise, not redistribute, I'm gonna advertise the loopback as well. Okay, so EIGRP from Tokyo is done. Okay, so the translator router is up. Okay, so there is nothing, no configuration now. Okay, so only interface configuration I would be having now. That's all. Okay, so on this Mumbai router 6, it's connected on the left side towards OSPF, and on the right side it's connected to EIGRP. So on my left side I have E0/0. I'm gonna say IP OSPF 1 area 40. Okay, and now they should become a neighbor, this and this router. Yeah, so you can see OSPF neighborship coming up. Similar way, let's focus on the second interface, that is this one. Okay, which is facing towards EIGRP router. So I say, okay, it's not interface IP, it's a router EIGRP 1 network. So what is it? It's 113.23.23.0.0.0.255. Okay, yeah, so the EIGRP is also up. So let's once check the OSPF. show IP OSPF neighbors. Okay, I have the OSPF, and on the same node, let's see the EIGRP. Okay, so I also have EIGRP. Now, do I have anything for 114 on my OSPF side? So if I see show IP route, so I don't have anything for EIGRP, right? And similar way on the Tokyo side, I will not have anything about OSPF. Okay, that's because we have not configured redistribution. Okay, so whatever routes are getting advertised, they are gonna limit to their own neighbors. Okay, they are now there are two different protocol, OSPF on one side and EIGRP on one side, right? So you need to set a common seed metric so that these can get advertised. So that's something which we will do now. So first I'll go to OSPF because it's very simple, you know that. So once I go to router OSPF1, and if I want to redistribute my EIGRP, okay, what is the AS number for my EIGRP? It is 1. I just took a very simple one. And what am I going to use now? So you know that while redistributing any IGP to OSPF, by default it's gonna take 20. Okay, and if it was a BGP, then it would have taken 1. So in my case it will take as 20. Okay, so I just need to say I just need to give subnets, that's all, because might be there are two or many routes that need to be redistributed, or might be within EIGRP1 there are couple of, or there are multiple prefixes. Okay, and you need everything to be redistributed, so that's why you give it as subnet. So that's how all of them are gonna get that 20 metric value by default. Okay, so I say enter. Now similar way I go towards EIGRP 1 and I give the command redistribute OSPF, and I'm making use of process ID 1. But in case of EIGRP, they are not very simple, okay, because they need all the parameters to be defined. So if I say metric and do a question mark, is gonna ask me for bandwidth, and bandwidth is nothing but it's my interface bandwidth. And in my case, I'm making use of very old routers which are running on Ethernet interfaces, which is 10,000 uh, bytes or 10,000 bandwidth. So I'm gonna say 10,000. So in your case, might be if you're using some giga interfaces or any fast Ethernet. So accordingly, you can change that. Okay. So in my case, let me tell you how do I know this. So let's take one of the interface. Okay, let's take this one. So if I see the interface summary, so I can see that this is my bandwidth. Okay, so this is my bandwidth. It's a 10,000 kilobits per second. So I just take this and I need to enter here. Okay, if I do another question mark, it's gonna ask me for delay. So do I have delays over here? So delay is this 1000 microsecond. Okay, and it's gonna be asking in microsecond itself. So I just paste it. If I do question mark, it's gonna ask me for reliability. So where do I find the reliability? Reliability will be, okay, it's 255 bar 255. Okay, so I'm gonna give 255. What is the loading or load? Okay, so basically the load is nil. Okay, or I can say the load is just 1. Okay, so you can see there is no much load now. So I give it as 1. What is the MTU? So by default, all the interface would be 1500. So where is it? Where is it? So do you guys, okay, it's over here. Okay, 1500. So I say it has 1500. So this are acting as a seed metric in the case of EIGRP. Fine. So I've done the redistribution, and let's see. Okay, and you can see the EIGRP routes getting learnt in the area OSPF. Okay, so if you see Mumbai router 4, which is a OSPF area, and you can see this EIGRP route. So they are basically getting redistributed. And do you see the cost value? Cost value of 20. So did you prove yourself with the theoretical approach that if you are redistributing any IGP within OSPF, they are gonna be considering 20, but you can change them. Okay, you can change them. And yes, because of this default features, there are two drawbacks of redistribution as well, which I'll tell you. Okay, because keeping default can sometimes leads to selection of a bad path. Okay, so I'll tell you what are those two drawbacks and how do you rectify them. Okay, but just understand now it's 20 because that's what by default they're gonna take it. Okay, let's see from the EIGRP router point of view. So if I do show IP route, so you see here that EIGRP is learning an external route 10.100, which is nothing but it's these network. Okay, and this is the metric. And why is this metric being getting calculated? It's because the values that you have been set, if you change your values, they are gonna change this. But if you don't set it, then they are gonna be infinity, and infinity is not gonna be getting included in your RIP. Okay, so you must give some metric in the case of EIGRP. If you don't set, then they will end up with infinity values and they will not get included in the routing table. Okay, so what about from the translator? So this translator must be aware of both the protocols. That's one thing. Okay, second thing, when you see the routing table, so you will see all those routes are already in the RIB or in the routing information, and those are the routes which get redistributed. If for some chance they are not in the routing table, then even though you just redistribute and you have those prefixes inside the redistribution, they are not gonna get redistributed, because the first criteria is that they must be in your RIB. Okay, second thing is something with respective to troubleshooting. If you see that everything is fine and the prefixes are not getting so let's say if there is some network here and the network is not getting learnt here, so might be there, then you have to troubleshoot, and that's when you have to see how is this prefix uh, is getting uh, learned. Okay, might be you considered EIGRP and EIGRP and OSPF, but in reality might be you had something like EBGP where where the AD value is much better than the EIGRPs, right? So in that case, you don't have to redistribute EIGRP and OSPF. It would be your EBGP and OSPF that you need to or you're supposed to configure. Okay, so that those are the two things which you need to take care. And yeah, the last thing over here are the issues what I was trying to say. Okay, okay, and there is one special command. Okay, that special command is when uh, you have IBGP and you are injecting this IBGP towards your EIGRP or OSPF. Okay, so when you have IBGP and you are injecting it, okay, so just remember to add this. So let's say you have router BGP 6500 and you're trying to inject the OSPF, okay, the normal process that you used. Just make sure you have a additional command BGP redistribute internal. That's when you have IGP, okay, not in the case of eBGP. eBGP will be the normal what we discussed. Okay, so the two issues here are, one is suboptimal routing and second one is routing loops. Okay, so suboptimal routing. So what is suboptimal routing? It's when you are trying to redistribute between two or more. Okay, if it is between only two, then you don't see suboptimal routing issues. So in case of 3, what happens is you're just redistributing and this is redistributing. So this router, the intermediate router, is gonna take all the metric associated with that route and it's gonna add whatever this router is gonna advertise. Okay, so basically you're losing its original identity. The first route uh, the identity of the first route gets lost, like what is the attribute or what are the metric or whatever the tags or something, it's get lost. Okay, so that's called as suboptimal routing. If you see here, it's a redistributing from one routing to another and the original routing source information is lost. Okay, because you gonna inject your own seed metric and might be that is different from what it was, right? So what happens is your whole network is now totally lose the original identity that this prefix initially had metric of 10. Okay, it just going to lose that and it's just gonna advertise or it's just gonna use uh, the latest metric what the translator did or the redistributed router did. Okay, so how do we rectify this issue is, so on a boundary router is one where the router is gonna know both of them. It knows, or I can say the translator router or the EI or the redistributed router. Okay, so you gonna make use of a metric which is you gonna calculate the right seed metric and you gonna input it. So in my case, if you remember, I just made use of the default value of 20, but might be that was not right. That might be the right one was 40. So I should calculate and I should make use of that right value to avoid this suboptimal routing and to keep its original identity instead of giving the default values or giving some customized value and it loses its original behavior or the original metric. So I can set the metrics. Okay, second thing is looping. Okay, the second problem that would raise because of redistribution is looping. So what happens is, let's say if I have RIP, EIGRP and OSPF. Okay, let's say RIP was sending to EIGRP and might be EIGRP was sending it to OSPF and now OSPF was just take an example that OSPF was supposed to send to RIP, but due to the change in the AD value, so this is second problem is more with respective to AD value, because when you do the redistribution, they're gonna move out of the previous AD and they're gonna they're gonna be achieving or they're gonna obtain the latest AD value, right? So because of the AD value, there can be routing issues. Now there could be possibility instead of OSPF sending to RIP, it's sending back to EIGRP, which is causing a looping circles, right? So this is one another kind of the issues. So the solution for this is to redistribute a route from one routing to another must be in the routing table. So just make sure whenever you're redistributing, make sure the routes are within that routing table. Okay, and if in case the routes are within the routing table, they are still gonna keep those AD values intact. Okay, they are not going to cause the looping route loopings in that scenarios. But if in case they were not in the rib and you redistributed, then yes, because of the AD changes, then there can be issues leading towards looping. Okay, so just make sure you are redistributing those prefixes which are already in the routing information database, so that you don't face any issues with redistribution. And there are some quiz, or there are some questions just to see. Okay, so you guys can go and check on this. They are very simple, not very major ones, and you will see some answers beneath them. Okay, so this was one of the simplest topic, and let me know if you guys have any doubts. Where is OSPF configured? So OSPF is configured here. Okay, and EIGRP is configured here, and this act as a translator. In real world, how to select the default metrics? Okay, so in real world we basically have to calculate the values. Okay, it cannot be we cannot set it to default. If we set to default, then it will lead to looping issue, or it will, because they are finally gonna lose their original identity, right? And might be the some other prefixes get preferred if it's getting advertised via static route or via something. So to avoid all those things, it's better you use the actual metric. So you can just see what is the actual metric, and you can accordingly configure. In the case of router 2, from each protocol connecting to other, and so where is router 2? Do you mean this as router 2? From each protocol connecting to other, and so if you keep your local connected interface, then yes, it's gonna redistribute. So in the case of redistribution, you can also redistribute the local connection. Okay, so let me show you. If I go to conf t, if I go to router OSPF1 redistribute, if you do question mark, you can also make use of your own connected routes. Okay, and you can just give whatever values you want, subnets, and they're gonna redistribute its own connected values also. So this is what I told you very beginning, that they are non-transitive. Okay, so only two routers are gonna communicate, or they're gonna redistribute their own connected routes, but whatever they are learning from the third one is not gonna get forwarded. To overcome this, we can make use of mutual redistribution, where we can advertise the first and the third one, so that they can follow the redistribution process. Actually, I didn't get this question. Okay, so if you can unmute yourself, and can you tell me, or if you can rewrite, then I can Okay, I think I got your question. So you mean to say if you're redistributing between the same protocols like EIGRP and EIGRP on other side, something like that, right? Yes, we do that. We often do it when we also have OSPF and OSPF. Okay, uh, let's say I have area 0, okay, XYZ company, and I just acquired another company ABC who were also running on area 0. And if you just connect them, so this is frequently asked question, how you gonna make neighbors or all those things. So the one best answer is you can have tunnel, okay, or you can also redistribute in this scenario. So they are not gonna get you looping, okay, so they are not gonna get you looping. So that is possible when you have two protocol. You can still advertise them like EIGRP into EIGRP or OSPF into OSPF. So that's possible, and it depends upon that scenarios, like what scenario you wanna redistribute. So any further doubts, guys? All right. So let's meet up in the next class. I take it as no from you guys. Okay. And yes, regarding the PDF, might be one of the PDF all of a sudden got corrupted. Okay, so you need not worry. Okay, so the thing is, just go one class ahead, or one other class, or the class which we took might be after that broken PDF, and that PDF will have all the previous classes. Okay, so how are these PDFs? So basically I upload them daily basis, but when I upload the next class PDF, they're gonna have my previous day class notes as well. Okay, I don't just keep on a class basis, I don't upload it. Okay, so let's say if I am uploading for EIGRP today, and on the next day if I upload it for OSPF, so this OSPF is gonna also cover all its previous day class. Okay, so if this is broken, uh, don't stop your labbing. Okay, you just go to OSPF, and from OSPF you can pull it back. Okay, so I'll check it from back end why it broke all of a sudden. One of the PDF is not working, so I'll just check that and I'll fix that. Okay, fine guys, so have a nice day, stay safe, and see you tomorrow with a new topic. Okay, have a good day.